So it is time already, so we are waiting for the people to join.
Good evening, everyone. Akinle, should I wait for some more time?
Good evening, ma'am.
Dr. Garima, you can start now. You can start.
Okay, okay. All right. So, a very good evening to everyone. And I welcome all of you here for Math with Purpose. And also, good afternoon, everyone in Nigeria. So, let me just share my screen with you all once and then I'll start. I hope my screen is visible. Is it?
Yes, it is visible.
Okay.
No, it's visible.
Thank you.
Wait for 5 minutes. Let it happen. Sharing key left, wait for 5 minutes. Let it go.
I can see that there are people joining in, so I'll wait for another 2 more minutes and then we can start.
Yes, please.
We are waiting for you, ma'am. We are waiting for you, ma'am.
Okay, so good evening, everyone. I'm Dr. Garima, and I would be talking on math can transform humanity. So it's like whenever I stand in front of a room which is full of people who love math or are actually curious about it, I feel something very special. So you probably don't realize how much power you're actually carrying. All those people were there. So when I'm talking about power, it's not power in a magical sense. It's not power that needs a wand or a cape or, some genius level of IQ. Just that power that comes from thinking mathematically. Because mathematical thinking, when I'm talking about mathematical thinking, I'm not talking about formulas, I'm not talking about speed, neither I'm talking about memorization. It is the same thinking that builds algorithms, it designs systems, protects data, drives innovation, and solves human problems every single day. So, yes, when I say we can transform humanity, I mean it in the most practical and the most grounded way possible. Math is enough. Math is more than enough, actually. And today I want to show you how. But before we dive in, let me officially welcome all of you from Nigeria, India, and everywhere else to this session on purpose driven problem solving using mathematical skills to create real world impact. So thank you so much, Akinle, for inviting me. It honestly feels amazing to see that conversations around meaningful math, the kind of math that shapes thinking, it shapes opportunity and society, are happening across countries, continents, and communities. I always say this that math has no borders. And today, seeing all of you here just proves that again. So, the topic I'm speaking on today is very close to my heart, the future of math education and how it can truly drive equity, engagement, and empowerment in the society. Because the future of math is not just about better scores or faster calculations, it's about making sure that every student, regardless of where they come from, can access the kind of mathematical thinking that opens doors to opportunities, to confidence, to meaningful participation in the world. And the exciting part, we are living in a time where mathematics is finally moving out of textbooks and stepping into real life, into technology, into innovation, into problem solving and impact. So today, let's explore not just where math education is going, but what kind of world it can help build. So before we talk about how math can create real world impact, we need to understand why a transformation is even necessary. Why I'm saying the transformation is important. Because students today are not living in the world our textbooks were written for. They're growing up in a world which is shaped by data. It is shaped by algorithms, automation, uncertainty, and problems that don't come with a step by step solution. Yet, most math classrooms still focus on memorizing procedures, repeating techniques, and solving artificial problems with one correct answer. So there's a huge mismatch between the world students live in and the math education they receive. And this gap is widening every year. So the transformation we're talking about today isn't a luxury. It's not a, nice to have it. It's urgent. Because the ability to think mathematically, to model, to analyze, to reason is now as essential as reading and writing. And here's the exciting part. Math can drive this transformation, but not in the way it is currently taught. We don't need more, formulas. We need more thinking. We need classrooms that build clarity, curiosity, and problem solving. That's the transformation we are here to explore. So let me show you one of the clearest reasons why transformation is not optional anymore. So if you can see this graph, this is from the World Inequality Report 2023. And it, tells a very simple but uncomfortable story. Look at the two bottom blue boxes at the bottom. The poorest 50% of the world's population, half of humanity, 50%, captured just 2% of the global wealth growth over the last 3 decades. Now look at the other side. The richest 1% captured 38% of all wealth created in that same period. That means for every step the bottom half of the world took forward, the richest 1% took 20 steps. Now, this is not just about money, it's about opportunity. It's about access. It's about who gets to shape the future and who doesn't. And the real danger is not the numbers themselves, but the systems that keep multiplying this gap. Economic inequality is not the only thing rising. So is emotional inequality also. So look at this global study from Gallup. Even without data, all of us can sense this shift. The anxiety, the stress, the exhaustion, the feeling of being overwhelmed. But the numbers confirm it. The global negative experience index, which measures anger, sadness, it measures stress, worry, has been rising steadily for over a decade. And the worrying part is that this is not limited to adults. It is showing up in teenagers, it's showing up in school children, even in the younger age group. So here's the connection. When the world becomes more unequal, when it becomes more uncertain, when it becomes more data driven and more emotionally turbulent, students need skills that help them think clearly, reason logically, and make sense of the complex problems. So they don't just need marks, they need mental models, they need resilience, they need the ability to analyze, model, compare, predict, skills that come from mathematical thinking. This is why transformation in math education is not just about academics, it's about well being, it's about agency, it's about giving young people the tools to navigate this very complex world. Now let me elaborate this. First, the math that I'm talking about, it builds clarity, and clarity reduces stress. So most of the anxiety young people face today comes from confusion, it comes from pressure, it comes from a lot of uncertainty which is there. Mathematical thinking builds the very skills that protect emotional well-being. Logical reasoning, it protects breaking down complexity. It gives you the confidence in problem solving. A child who learns to think clearly becomes an adult who can navigate life clearly. Second, math opens opportunities, and opportunities reduce the inequality gap which is there. So according to global reports from WEF, LinkedIn, Forbes, OECD, nearly 80% of the fastest growing, highest paying careers rely on analytical reasoning. They rely on quantitative thinking. They rely on modeling. They rely on data literacy. These are all math-based thinking skills. So when students from any background gain these skills, their career possibilities obviously expand. And that is how equity is built. But here's the real insight. Math cannot transform society unless math education transforms first. If we continue teaching math as, memorization, as procedure, we lose the very power that math has. But when math is taught as reasoning, it is taught as exploration, it is taught as modeling, it is taught as problem solving, it becomes one of the most powerful engines for human transformation. And this brings us to a difficult truth, a truth we must face honestly if we want to change. Now, to understand why math is currently not creating this transformation, we need to face the truth about the state of math education worldwide. Now, this is not an India issue. This is neither a Nigeria issue. It is a global issue. Look at these findings. You can just spot on the slide. UNESCO reports that 6 out of 10 children globally are not reaching minimum proficiency in reading or mathematics. There's another one by UNESCO, which shows that in many countries, over 80 to 90% of learners aged 10 to 16, they lack the foundational basic math skills. There are surveys across the UK, US, Asia, and Africa, all point to the same pattern. Children fear math more than any other subject. Even global leaders, acknowledge this. From Rishi Sunak, he's advocating stronger math education in the UK. Sometimes back, I happened to talk to Mr. Richard. He's the founder of Art of Problem Solving, which is one of the most prominent organization working towards improving math education in the US. And he also said the same thing. The way we teach math is not preparing learners for the world they're entering. Even Dr. Jo Bowler from Stanford University, I really admire her work. She's an inspiration to me. She says the same thing too. The key question here is, which I want to ask everyone out in this world. If humans are naturally wired for logic and patterns, then why do children struggle with the very subject which is built on those strengths only? The answer is very simple, according to me. It's not the children who are failing, it's the system which is failing them. We are teaching math in a way that suppresses curiosity. It disconnects it from real life. It reduces it to procedures and memorization. To show you exactly what I mean, I want to take you through a few very, I want to take you through few questions, very simple questions every child learns in school. And as mathematicians, I know you will answer them correctly. But the point is not the answer. Please understand, the point is what these questions reveal about how math is taught and why children across the world are struggling. So let's look at them. So the questions are there on the slide. The first question that I have is, what is 8 by half? Please answer them. You can write it on a piece of paper or whatever. Is 8 minus 1 same as 8 minus 2? Is 5 times 4 different from 4 times 5? Are 8 by 2 and 16 by 4 same? Just think about these questions. Ponder over it. I know you and I can answer these questions instantly because we already think in structures, not just symbols. But for millions of children out there, these questions create confusion. They create fear and self-doubt. And here's the surprising part. This confusion is not accidental. It has historical roots. Something happened in mathematics nearly, some 200 years back that quietly changed the way children learn math today. Let me show you where this began. So 2023 marked a quiet but important milestone in math education. 200 years since intuition, visualization, and concrete reasoning began disappearing from school mathematics. Let me explain this to you. In 1823, the famous French mathematician Augustin Cauchy published his landmark work on calculus. So he formalized and abstracted the subject in a way that transformed science forever. This abstraction was brilliant. It fueled breakthroughs in engineering, astronomy, physics, medicine, and later computer science as well. So professionals needed that level of abstraction because it enabled massive progress. But something else also happened. Over the next few decades, the school version of math also became abstract. Too abstract, too quickly. By the mid 1800s, math in classrooms had shifted away from real life, intuition, and sense making. And this is where the gap began. Math became a subject of formulas, rules, and symbolic manipulation long before a child was cognitively ready for that level of abstraction. So abstraction is not the enemy. I'm not saying that. In fact, for adults, abstraction is very beautiful and very powerful. Professionals use abstraction to simplify complexity, generalize ideas, innovate, solve large-scale problems, reuse methods across fields. But for children, the story is absolutely different. Children learn best through concrete examples, real experiences, visual patterns, physical models, stories, and contexts. So when abstraction comes too early, the actual meaning is lost. The confusion grows because of that. The concepts feel disconnected. The relevance of the problem disappears. The confidence, and henceforth the confidence collapses, and creativity gets blocked. So this is not a child's failure. This is a design failure in math education. Now let's return to the simple questions I showed you earlier. I would want you all to go ahead and answer these questions. What is 8 by half? Please answer it in the chat box. Please answer it in the chat box, everyone. It is 16. I can see people writing 16. I would say it is not 16. Please mute yourself. Yes. So let me now state a universal definition of division, which will be applicable in every situation, everywhere. So you can read a division expression A by B as how many B's in A. So 8 by half is how many halves in 8. Like how many half apples in 8 apples. So there are 16 half apples. Everybody wrote it as 16. Nobody wrote it as 16 halves. And I've asked this to hundreds of people, and none of them till now have been able to tell me what the 16 is. How can something which is divided in parts can become more than the whole? So 16 is not correct. It is 16 half apples or 16 halves. The whole always remains the same. It just got divided in halves. So it is 16 halves and not 16. You can apply this definition to any number, be it 4 by 2, be it 5 by 2, be it 400 by 200 or 200 by 400, anything, any other numbers. So when a child shares 8 chocolates among 16 friends, that's a real life division model. But when they see 8 by half written as symbols on paper, they're expected to jump directly into abstraction without first understanding the concrete idea of sharing. What is this 8? What is this half? Children understand actions. They break apart, group, share, compare. We jump too quickly to notations, be it addition, subtraction, multiplication, division, the parenthesis. This gap between what children naturally understand and what symbols demand is where learning breaks. Now let's return to the simple question again. I would want you to go ahead and again answer this one now. Tell me, think of a real life situation where 8 minus 1 minus 1 is different from 8 minus 2, or do you think it is same? Do you think it is same or they're different? Tell me why. Please write it in the chat box again. Is 8 minus 1 minus 1 same as 8 minus 2, or is it different? If it is different, how? If it is same, how? I want people to answer this. I'm waiting for someone to write the answer. Same, because you can subtract from the same unit. Okay. Anyone else? It can be 8 also from a child's view. Same abstract, but not in real life. That's true. It's not the same in real life. And the answer is same. When we say the difference between the two is same, 8 minus 1 minus 1, which is 6, is same as 8 minus 2, which is 6. However, the real life situation is very different. It is very different. So, Kiran, if you can just see, it is 8 minus 1 minus 1. It is not 1 minus 1. It is 8 minus 1 minus 1. So 1 minus 1 is not, I mean, you're writing it as 1 minus 1, which is 0. So therefore, 8 minus 0 is 8. No. You should just check. It is 8 minus 1 minus 1. As per Esther, it is Esther. Sorry if I'm correct. I mean, pronouncing it correctly. It is same. Yes, abstract, it's same. However, when I talk about real life situation, it's like something I have 8 pens and I give one to one of my kids and the other one to other one. So the real life scenario is 8 minus 1 minus 1. But when I give both pens to my one child, it becomes 8 minus 2. So that there's a difference in the real life scenario which is there. Let me come to the next one. What do you think of the expressions 4 cross 5 and 5 cross 4? Do you think it's the same or different? Come up, everyone. Please write down your answers, whatever you're thinking. Is it same or different? Different. The process is different. The product is the same. They're different. So, again, a universal definition for multiplication. 4 times 5, algebraically same, geometrically different. The physical realities are very different. So 5 times 4 is like you have 5 sets of 4 pens. Just visualize this in your mind. It is 5 sets of 4 pens, or you have 5 baskets and each of it has 4 apples. That is 5 times 4. On the other hand, 4 times 5 is you have 4 baskets and each is having 5 apples. So that's 4 cross 5, and the previous one was 5 cross 4, 5 times 4. So 5 of 4. So 5 is supposed to, in 5 into 4, 5 is supposed to be the multiplier. 4 is supposed to be the multiplicand. That's the real life situation that I'm talking about. However, what we tell to students is 5 into 4 is same as 4 into 5. We don't even know how we are doing the tables with them. Okay, so let's come to the next one. Are 8 by 2 and 16 by 4 same? So for us, 8 by 2 and 16 by 4 are both equal to 4. But in real life, they represent completely different scenarios. Can anybody tell me? Explain it in the chat. How is 8 by 2? The quotient is 4, and 16 by 4, again, the quotient is 4. How is it different? Or do you think it is same? How many 2s in 4 and other is how many 4s in 16? It's different. Yes. So as I previously told you, the universal definition for division, if A in A by B, it is how many B's in A. So when I'm talking about 8 by 2, so it's like, so you have 8 apples, and how many 2 apples are there in 8 apples? So there are 4 groups of 2 apples in 8 by 2. However, when I talk about 16 by 4, so you have a set of 16 apples and you want to find out the groups of 4 apples in that. So there are 4 groups of 4 apples. So the quotient is 4. I agree. Abstract is right. However, 8 by 2 is 4 twos. And in 16 by 4, it is 4 fours. Okay, you're just regrouping those 16 into 4 groups of 4, and you're regrouping 8 into 4 groups of twos. So that's the real life scenario which is there. So today we can see the difference easily and might wonder about, these small insights. Do they even make a difference? Because we can abstract. That part of our brain is very well developed now. But a 7-year-old, if you go down to that level, an 8-year-old, they can't abstract. They need to see, they need to touch, they need to feel to actually learn. They need to see the apples lying in front of them, But expression like these, abstract math, too early for these children. And they get lost in symbols before they've even had the chance to build understanding. Every educator knows the right pedagogy goes from, you go from concrete, you go to visual, you show it in symbols, which is symbolic, and then you abstract it. But math education today often starts at abstraction to abstraction to abstraction. It is all about abstraction. And then we wonder why children are struggling. So this mismatch between how children learn and how we teach is the real reason for the global math crisis which is there. Now, the bigger context. The world we are entering is powered by mathematics, from the algorithms that recommend what we watch, to the encryption that keeps our banking safe, to the models that predict weather, traffic, and even disease outbreaks. Math is no longer just an academic subject. It is the engine behind almost every modern system that exists. But when we learn math through stress instead of intuition, we grow up disconnected from the very skills the future demands. And here's the deeper truth. When math becomes painful, children don't just dislike a subject, they begin doubting themselves. Math anxiety quietly, the anxiety that they have because of math, that quietly grows into learning anxiety, that grows into performance pressure, that grows into loss of confidence, that goes into stress, again avoidance because of that, and sometimes even emotional withdrawal. Now this isn't just about grades, it affects your identity itself. So a child who believes I'm bad at math often begins to feel I'm not smart enough. Now this feeling spills into other subjects too. That again goes to adolescence and eventually into adulthood. But here's the opportunity. If we heal math at its foundation, we heal a major part of childhood anxiety. If math, when I'm talking about that, I'm talking about if math becomes intuitive, it becomes visual, it becomes real life, and it starts making sense. We remove a major source of stress from millions of young minds. And only a confident child grows into a confident adult. Only an empowered child grows into an empowered citizen. This is where math's true power lies, not just in equations, not in any other formula, but in human potential. So, what does all this mean for us? It means the transformation we dream of won't come from any kind of policy reform alone. It starts with us. We are uniquely positioned because we can now see the beauty behind the symbols. We can understand the intuition behind abstraction. We can travel back and forth between concrete and abstraction. And we can make math meaningful again. The hardest thing in education is your mindset shift, but it starts with us. If we intentionally, bring clarity, intuition, and real world meaning back into math, we become the catalysts for global transformation. We are not just teachers or learners. We are the superheroes of this story. And when this transformation happens, when math becomes accessible, it becomes intuitive and empowering, children will grow into adults who are confident, who are emotionally resilient, they're engaged, they're economically empowered, and capable of solving every real world problem that exists. So, a more equal world begins with a more empowered learner. And empowered learners are built through empowered math education. So, this is how mathematical thinking transforms humanity. So, thank you from my side, and I'm open to any kind of questions. Thank you, Akrur. Thank you so much, Kiran. If you have any kind of questions, you're please free to ask. Thank you, Veena ji. How do we take this to schools as per Amitabh ji? Okay, so when I say that the transformation happens from us, so we should be the ones who are taking this to school. You cannot expect the entire school to change, right? Thank you so much, Esther. We can't expect the entire school to change. So the transformation has to start from us. We should be the ones who take it to the class first. Once we're able to convince the parents, once we're able to convince the students that we're on the right path, I don't think so there's any looking back. And once the kids, so you have to lay the foundation right. You can't expect everybody to do it. You do it. That is how we can take it to schools. Thank you, Akinle. Thank you, Smita. So, Pramodji, thank you so much. How to apply and practice aligning with school curriculum. So, when I'm talking about, what we usually do as teachers is, so I've been a teacher throughout. What we usually do as teachers is we lay more stress on doing the worksheets, on doing the questions, on doing, practicing more and more questions. That won't help. That won't help at all. So, rather focus more on the conceptual understanding, lay more stress on the concept. We do it the other way. We just take the concept for maybe half an hour and then keep, solving the questions. It should be the other way. Lay more stress on the concept. Try to make the concept absolutely visual to them. Once they're able to see it, for example, fractions, for example, any kind of operation also. Once they're able to see it, once they know how to think, I think then solving the question is not a problem at all. Amitabh ji, yes, you can actually, so we have also built up books on for mathematics. That is all that matters in math. That's available on our website. So I think we can share the link to our website, which is uncovermaginous.com. You can go and check the books that are there. So all those books, so I've been a co-author in that, and all those books are built on the understanding that how children actually learn, how you can make all these concepts visual to them. Anyone else?
Sorry, ma. Good afternoon, ma.
Good afternoon.
Good afternoon, ma. Thank you very much, ma, for your section.
Thank you so much.
I have a question to ask.
Yes.
Because someone also asked, like, yes, but I just want to hear from you too. We see, like, especially in Nigeria, yeah, we see that so many people, so many children, they have, but I say the word hatred for mathematics, in the sense that maybe they don't like the way it's being taught, or there's no practical ways that are being taught. So I would like to ask, like, what practical ways can we integrate into teaching them, that they'll be able to love mathematics again, or try to understand it more, that'll make them go from, oh, this math is hard, to I love how this is being taught. Yeah. Thank you, ma'am.
Okay, so my answer still remains the same as what I just told to Amitabh ji. I agree. So this hatred word is just because they're not able to see things. Why do they love movies? Because they can see it, right? Same ways, when they're not able to see maths, how would they love it? Okay, so I would want that all the concepts be visual to them. So till fifth or sixth, till sixth actually, all the concepts are basic concepts, right? Till fractions, you come to linear, all those concepts should be made visible to them. Once they see how fractions look, why would they hate it? Okay, why would they hate it? What is 1/4? How do you see 1/4? How do you do at all the operations in the fractions? How do you do it? You actually abstract it. You tell them you have to take the LCM and then do the butterfly method or whatever method. Now, my thing is, what I'm saying is, make it visual to them. And I'm telling you, don't need any tools for that. You don't need any tools for that. You don't need any kind of Legos or anything for that. You just need simple strips of paper around you to make it visual to them. And once you start doing it, once they have this with them, once they can see what is 1/4, once they can see what is half, would they not be, curious in telling what could be half plus 1/4? Obviously, when they have some hands-on activity with them, they'll be very curious. They'll actually start loving it. So my suggestion is that make it visual. Go to any extent to make it visual to them. Once you do that, there'll be no word as hating math. They'll all start loving it. How can we, Esther, I hope I answered your question. Thank you so much. How can we help children learn improper fractions using visualization? See, all these, thank you, Esther. All these terminology, what is improper fraction, what is proper fraction, what is mixed fraction, they're all terminologies. My first thing is, what is a fraction? How do you visualize a fraction? Very simple. If I ask you to tell me what is 1/4, how would you do it? You have a strip of paper, take it into 4 equal parts, and you show what is 1/4 to them. And similarly, if you have to show them what is improper fraction, first they need to understand what is 5/4. That's an improper fraction. What do you mean by 5/4? It is 5 parts of 1/4. Just keep showing it to them. So you have 1/4, you have another 1/4, you have another 1/4, you have another 1/4, and you have one more 1/4. That's 5/4. That's it. So once they see what is 1/4, once they know what is 1/4, once they know what is the meaning of 5/4, they can actually see what is 5/4. So they don't need to learn anything. They just need to visualize the fraction. Let them do it. Give it to them. And they'll be able to do it on their own. Once you explain what is 5/4, it is actually not 5/4. It is 5 of 1/4. So 5 parts of 1/4. Show them 1/4. And they know what is 5 of 1/4. 5 such parts. They know it already. Thank you. I believe, okay, Akinle has a question. In Nigeria, many people believe whoever studies mathematics, they meant to be a teacher. What is your thought on this? So that's a beautiful thing, actually. So you don't need to be a teacher. If you're good at maths, you can do so many more. You have so many more professions if you're a mathematician. But yes, teacher is something which is, as a profession, it is very close to my heart because I've been a teacher throughout my life. And I think a teacher is a person who can actually transform a child's life, right? So even the parents rely on the teachers to do that, right? So I would personally want that all the youngsters who are there, they should actually try to at least not be a teacher, but at least transform, whoever can, transform a child's life. They should be able to teach. They should be into this profession, because now I see that the youngsters are not moving into this profession. They're moving into this profession not out of passion, but because of compulsion. I see this in India, at least. So out of compulsion, it is just another profession for them. But unless you have that passion for teaching, unless you have that that thing in you that you have to change somebody's life, that the teaching will not, it will not come out of it. You have to grow yourself. You have to keep it in your mind that yes, you're doing something for your kids, you're doing something for this child. And in a class of 40, in a class of 30, even if you're able to do it for one child, that means you've made a difference. So the passion has to be there. So yes, if you think, if the people in Nigeria think that whoever is studying maths, they mean to be a teacher, that's good enough.
Okay, ma. Thank you very much, ma. Ma, I have another
Thank you so
question.
much. Thank you so much,
Yes.
Esther.
Ma, I have another question, ma. So,
Okay.
when we teach students, there's just a common question that they always ask, and sometimes it get us thinking. Let's say, for example, you're teaching them fraction, you're teaching them differentiation, you're teaching them addition, subtraction. They're always asking, where does this apply? Like, how do I apply it to my mathematical thinking? How do I apply it to solve real problems? So I just need like some problems that we can really apply this into, so that in case we are being asked, we know how we can be able to approach the answers.
Mm-hmm. Okay. So basically, so since I have been into higher education for a long time now, I can completely, sense what you're trying to say, that they don't know where to apply these things. In fact, all the basic foundational maths is still you can apply to, higher mathematics. But when it comes to higher maths, they don't know where to apply what. So I don't know if you know about algebra. So in higher education, we talk of more of analysis, we talk of more of algebra. Okay, the advanced level actually. And then even the students there, they ask me, Ki, where will I apply this? I have just one answer to this. Mathematics just opens up your logical mind. You start thinking in that direction. You may not be able to apply every concept that you've learned to, everywhere, but you start thinking logically. You start drawing the patterns which is there. And mathematics is all about finding patterns. If you're able to find that out, so that means you will be able to find patterns in every concept, every subject actually, right? So I always answer this to my students also, and I mean, it's up to you obviously. So mathematics just opens up your logical mind. And in fact, if you're saying that even a class, 4 or 5 kid asks ki, where will I apply this? In fact, all these basic skills, you talk of percentage, you talk of fractions, it is everywhere. I mean, percentages, you have sales and discounts, you have, profit and loss. There, the percentages are there. So the basic concepts are anyways there in higher classes, and in fact everywhere in the real life scenario. But when it comes to even for the advanced, for the higher education, there it's more about opening your logical mind. You start thinking in that direction, and in fact, after that you go into any profession, you go into, being a data analyst, you go into finance, everything. There you don't need any other skill, you just need your thinking skills, because now, because of AI and chat GPT, you have everything available so readily, right? So you just need to think in that direction, and that thinking you get from doing the right mathematics. Okay. Anyone else? I think I've answered most of your questions. Acha, there's another one by Pramodji. Any specific book reference which covers today's visualization idea on basic concepts? Pramodji, you can go to. So we have already built those books. They're available on the website, which is by the name of uncovermatchiness.com. You can go and check out the books right there. So we have already co-authored and authored those books. Thank you so much, Esther and Veena ji. How to learn calculus from basic to advanced. Okay, so calculus is the most real life mathematics because it is the mathematics of change. We never talk of average speed. We talk of instantaneous speed. The speed which is, so when you look at the speedometer which is there on your car, what is it? It is the instantaneous. It tells us the speed at that particular moment. That is the most real life mathematics which is there, calculus. But again, the problem is the system where calculus is just reduced to differentiation and integration. However, there's much more understanding beyond differentiation calculus. Pramoji, please share website name details here on the chat or in the WhatsApp group. Okay, we'll do that. Thank you. So coming back to calculus, it's when I'm saying that it's the most real world is because we always talk of the instantaneous speed which is happening. When you look at the speedometer while you're driving the car, it is the speed at that particular instant. It is not talking about the average speed. However, we usually talk of the average speed. What is the average speed when we travel for an hour, right? But we usually see on the speedometer the instantaneous speed. So when it comes to instantaneous speed, that is actually the derivative that we're talking about, right? Derivative of that we're talking about. So again, to learn the basics to advanced for the calculus, we need to see calculus in all these bits and pieces. We need to see where calculus is actually happening, because otherwise calculus is just a set of rules. I don't know how many formulas you have for differentiation, how many formulas you have for integration, and we're done. I remember in my school days sitting from 12 to 3 at night just to do the differentiation and integration part without even understanding what we actually know about differentiation and integration. I'm not saying that I did not score well then. I scored very well then, but I did not understand what is differentiation and integration. So main thing is we need to understand the concepts of differentiation and integration. Again, if you go on the site, Ayush, if you go on the website, I have written I've co-authored a book myself with my mentor, which is on calculus, the basics of calculus. That's uncovermadgenius.com. So there, so it's again, we just need to understand geometrically the very basic meaning of derivatives and integral. Once we understand that, after that, everything is abstract. Everything is abstract. All the formulas that are there, they're all abstract. So the problem is the students feel that differentiation and integration are very difficult. Why? Because they are just into the formulas. I am saying is make them understand what is differentiation and integration and then tell them to do and solve the question. Go and solve the questions. That's it. They anyways have to do it. They have to do it to survive the math exam. They have to do it. I am not denying that. So again, when I say this, I'm not anti any formulas which are there. What I'm saying is formulas is an outcome of the visualization process. First, make them see, make them touch, make them feel, make them see calculus or any other concept which is around. Where do we see percentages? Don't just tell them percent means this. It is 40% means 40% of whatever. No. Tell them the real life scenario which is connected to the percentages or to calculus, and then go outward. Then go into the world of abstraction. Abstraction, anyways, as I told you, it is very beautiful. You know, abstraction, just because of abstraction, you can actually do any kind of mathematics, any kind of concept. I'm not denying that fact. But the first thing first is visualization. So make them understand the very meaning of derivative, the very meaning of integral. Why was derivative invented? Why was it actually discovered? Not invented, but discovered. Why was limits? Limit is the main concept of calculus. Why was limits even required? They were all discovered. So this is what is need to be told to the students. And once you tell them, once they feel that connection with calculus, rest is very easy. Rest, so they can do all the questions on their own. Thank you, Ayush.
Oh, thank you so much, Ma.
Thank you so
I
much.
really appreciate it. So thank you. Thank you for your time, Ma.
Thank you. It was lovely interacting with everyone. Thank you so much. Thank you. Do you have any course on calculus? Ayush, you can go and check out the website which is there. I'll write it down for you. It is you can go out and check the books which are there. You will get an idea. Right? Okay. Thank you so much, everyone. And best wishes to all. Thank you. Thank you so much. Thank you so much, Akinle, Esther. Thank you.